Right. So chapter 7, let's kind of look at chapter 7 as a whole. Chapter 7 has 7.1 through 7.6. Looks like we have a quiz after 7.3. And then at 7.6, we'll have a test after we're done with that. We're going to talk about similarities in 7.1. So we're going to talk about similar polygons, 7.1, 7.2. We're going to do similarity and transformations. 7.3, we will do triangle similarity. And then 7.4, we'll move on to other things. All right. 7.1, let's go to page 466, ratios in similar polygons. Anybody tell me what a similar polygon is? And what is it different from? What have we talked about so far when we talked about polygons or triangles? We talked about what? We talked about congruent ones, right? We talked about congruent triangles, right? Holden, give me one way that a triangle can be congruent.
Like you can have all the same angles.
All the same angles?
Or no, all the same lengths.
All the same length. So side, 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 right? Side, side, side was one. Right? Okay. Sophia?
Side angle side.
Side, angle, side. Anybody else? Blurt it out, please.
Hypotenuse leg.
Hypotenuse leg.
Angle, side angle.
Angle, side, angle, right? Okay. All right. What was not one? We said that SSA was not one, right? Okay, this is one of the ones that we said that was not. Okay. So you have these three, and then you have the hypotenuse leg. Okay. All right. That's just kind of a quick review of our congruent triangles. Today we're going to talk about similar triangles, similar polygons. Similar polygons are polygons that are not congruent, but they're the same general shape, right? In other words, I can have a rectangle that looks like this, and a rectangle that looks like this, right? And I can say that they are similar as long as the ratios to the corresponding parts are the same. Okay, these ratios to this, this to this, this to this, and obviously the angles need to be the same, right? Okay, since I told you they were rectangles. Okay, so let's go to similar polygons. The definition is there in the middle of page 466. Two polygons are similar polygons if and only if their corresponding angles are the same, congruent. Okay, the corresponding angles are the same, and their corresponding side lengths are proportional. In other words, they carry the same ratio. Okay, so if this was 1 and 3, and I told you this guy was 2, what does this length have to be? 6, right? Can you see that? Because I went from 1 to 2. I blew it up by 2 times, right? So this has to go 2 times also. It has to be 6, which would mean this would be 6 and this would be 2 also, right? Okay. The same ratio, their proportionality stays the same, okay? Example number 1, identifying the pairs of congruent angles and corresponding sides. Okay, so we have 2 triangles here that are similar. And we have, looks like this. QRSQ 930 13.5 and 18. We have an angle here, an angle here. Okay, so notice they kind of flip-flopped it in a smaller one. Okay, we have this angle, which is the corresponding spot. Angle is over here. This angle is over here. Okay. We have X, Y, Z. Okay, and we have 9, 6, and 12. Okay, blah, blah, blah. And what are we trying to find? Identify the pairs of congruent angles. Corresponding side. So, what is the corresponding side to QR? YX?
Oh,
YZ, right? Actually, it is YZ, not ZY, right? Because we're going from this side to this side, correct? Okay. What is the corresponding length to QS? YX, right? What is the corresponding angle to angle S? The angle X, right here, right? Okay. Let's look at the proportions, make sure they're the same, okay? This is 18 over 12, 18 over 12, right? Then here we have 9 and 6. And over here we have 13.5 over 9. Are they all the same? Are they? This would be what? 2 over 3? This guy is 2 over 3. 2 over 3, right? So they're all the same. You see the ratios have stayed the same. So they must be similar polygons, right? Okay, let's go to top of page 467. A similarity ratio is the ratio of the length of the corresponding sides of two polygons. We just did that, okay? Example number 2, identifying similar polygons. Determine whether the polygon is similar. If so, write the similarity ratio and the similarity statement. Okay? So, blah, 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 blah. Number 2. Example number 2A, we have 4, 12, 6, 16, 4, 12, 6, 16. This is A. First one is PQRS. Next one is TUVW, TUVW. Okay. So determine whether they are similar. So, and they are, okay, does it really say here that they're rectangles? I guess it does. It says rectangles, PQRS, and TUVW. Right? Since we know that they are rectangles, that means that all of these angles here must be 90 degrees, which means that every single one of the corresponding angles are the same, correct? Because this one would correspond to this guy, this one to this one to this one to this, and they're all 90 degrees. So we verified that all of the corresponding angles are congruent. Okay, so let's get the ratios now. The ratio here is 4 to 6. And this one over here is going to be 12 to 16. Are they the same? No? Yes? Maybe? No? This would be 3 over 2. This guy's going to be what? They don't look the same to me, do they? All right, so they have a different ratio, okay, which means that they are not proportional, so they're not similar. Okay. What would this have to be similar? If I were to fix this, what would it be? What does it need to be? 18, right? Everybody got that, why it's 18? Because if I'm going to go from here to here, I multiply this guy by 3, which means that I must multiply this guy by 3 also. So if this guy was 18 instead of 16, then it would have been a similar rectangle, correct? Right? Okay, so that's A. Now let's look at B. B, we have A, B, C, and D, E, F. Okay, A, B, C, and D, E, F. A, B, C. Then we have D, E, F. D, E, F. And we are given that this guy and this guy are the same. And then we are given that this guy and this guy are the same. And the lengths are 16, 20, 24. The lengths over there are 12, 15, and 18. 12, 15, and 18. Okay, so the question is, are they similar? Okay, so let's look at the angles first. I have these two angles are the same. These two angles are the same, which means that these two angles have to be the same, correct? Why do they have to be the same? Nope. Anybody else? What is the sum of the angles of a triangle? 180, right? So this angle is going to be 180 minus this guy and this guy, correct? This guy here is going to be 180 minus this guy and this guy, so they must be the same, correct? Everybody see that? Right? So that's why the angles are congruent. Okay? All we have to check is now is for the lengths. So the lengths here are this guy to this guy would be this guy to this guy, correct? So let's say this guy to this guy, 20 over 15, right? This guy to this guy. This guy to this guy is 24. So the corresponding part would be this guy to this guy, 18. And what do I have left over? 16 and 12. Are they all the same? Divide by 5, I get 3/4. By 6, divide by 4. Looks like they're all the same. Okay. So here's the tricky part. And now they asked us to write the similarity statement. This is just what we did. This is the same as we did with the congruence statement. Remember I told you when we're doing the congruence statement that each corresponding point has to be correct, right? Same thing here, okay? So triangle ABC, let's go ABC. So what's the corresponding part to A? D, right? So the triangle D, B will be the one over here, right? E, F. Okay. The statement you're going to write is going to look like this. Okay. Remember when we did congruency, we said they're congruent like this, right? This is the statement for similarity. Okay. Similarity statement looks like this. Okay, so that's that. Go ahead and flip over to example number 3. Railbox boxcar can be used to transport auto parts, if the length of the actual boxcar is 50 feet, and the width of the actual boxcar, find the width, actual width, okay. So what you have there in your book is a model of the boxcar. Right? But if it was to scale, and we're going to assume it is to scale, right, meaning that the ratios stay the same. So in the model boxcar, right, we have the top was 7 inches, is it? To 2 inches? Is that what it is? 7 inches to 2 inches, right? So on the real one, right, on the real one, we are told that the length? The length is 50, right? This is 50. We want to know what the height is, the width is here, right? So this to this is this to this, right? So this to this is going to be equal to 50 to 7. Right? Okay. Carter, what's my next step to solve this?
Well, it says it's 50 feet, so wouldn't you have to convert the feet into inches first?
Could if I needed to, okay. So let's try it without converting first. See how it works, okay?
Okay, so, well, then.
Well, what would I do here? What would I do here?
You can cross.
I would cross multiply, right? Cross multiply. So I'm going to multiply here, and call it the same 100 over 7, right? And this is going to be in what? Since this was in feet, this would be in feet also. So it's going to be this many feet, correct? Okay. So Carter's concern was that, well, since this is in inches, wouldn't this guy have to be in inches also? Okay, so if I want to change this into inches, how many inches are there? Times 12 inches, correct? Right? So then this guy here would be times 12, right? Which means that my answer would be times 12, but in inches. It's the same thing, correct? And the reason why it's the same thing is because this is inches, and up here is feet. So you kind of see how they cancel out. Good question, though. Okay. All right. So that's how you would work that, right? Okay. So the actual answer is going to be, as we had before, this many feet. And we're done. Any questions?